How useful is ASE and do you need it? And what the hell is ASE anyway? I get a lot of requests on how to calculate ASE with the Ladybug tools, and we will look at that later in the tutorial. And how useful it is depends entirely on you, on what you want to achieve and what your task is. And we will talk about that as well. But first up, channel member shoutouts. Hey, this is so exciting. Johnny Stein, you tell me. Thank you so much for joining my channel as a member. It's a pleasure and an honor, and it means a lot. This makes me very happy to get a response on the effort of my output. Johnny also has a channel. No videos, but loads of playlists and lots of music I can see. Gute Musik, gute Rockmusik. I saw some stuff here. I think, yes, Dire Straits, Sultans of Swing. Big fan. A few years ago, I saw Mark Knopfler on the O2 Arena. Awesome, man. I will go through because I think there's some really interesting gems of the music history in here on your playlists. And Johnny had a request. We will talk about that in future videos. The request, I think, pairs fairly good with also Raphael's request. So Raphael also had a request, and I'm thinking a few months on how I could start with videos which are more focusing on realistic projects, but more to that very soon. Okay, now, how to calculate the ASE, annual sun exposure, and how useful is it? Well, imagine glare. Glare is very cool in photography or in filmmaking, but it's not very cool in an office environment. People cannot concentrate or get a headache or problems with their vision. That's not what you want in an office environment or in a school. You actually try to avoid any direct sunlight going into your room. You want daylight for sure. You want loads of daylight, but you don't want direct sunlight. And that's and that problem can be calculated to some extent with the annual sun exposure. I'm critical though, because I feel it's not it gives you some idea of the problem, but I think there are better tools out there which can tell you more. Nevertheless, sometimes you can't avoid it because you actually need it. You need that specific calculation. Now, there are two scripts out there. One is from Chris Mackey, the master himself. I will post the links in the show notes. He did one script for the legacy tools, and another brother from another mother, Abraham Yesioro, I hope I pronounced it correctly. He did also a script. He did his own version for the new Ladybug tools based on Chris's example. Okay, where to start? Well, I think we will build our own ASE calculation or simulation. But first we need to understand what that actually is. I downloaded Abraham's script because I think it's a good way to start learning about what we actually want trying to achieve. One thing is a bit confusing here because he has the SDA on top, the SDA simulation on top, and then he has the ASE simulation on the bottom. We focusing on this for now. What's good is by looking at other people's script is that you can see a certain workflow that you might want to adapt. You also see that your installation is correct or not. If you download this script and it doesn't show you this output here, then there's something wrong with your installation. But then also, what do we actually calculate? What is the output here? We can see hours from 0 to 1000. We can see here we have the heat map with numbers on it, and we have ASE is larger than 250 by 10% and then 28.9%.
You have failed lead.
Well, actually not. You have not failed lead. But the definition, why do we actually need SEA? The SEA is calculated for a certain lead credit. So if you want to have a LEED certification for a building, kind of try to gather points through different criteria of that building. And the ASE, the annual sunlight exposure, is one of these criteria. The 250 by 10% is a threshold. So what does it mean? We have the hours here. What's in here written are the hours of direct sunlight hitting that surface. So over the whole year, we had 668 hours with full direct sunlight. You can see here 250. 250 would be the threshold. So based on the LEED certification, you should not exceed 10% of your entire surface with areas which have more than 250 hours of direct sunlight exposure. In that case, we have 28.9%, which is way over. It's more than double the percentage. And that's why
You have failed LEED.
now let's create our own script. I'm gonna start a new file. What we need is a honeybee model. I will not explain you how we create a honeybee model. Please, for that, check my playlist Honeybee 2022 and start from the beginning, the installation. So we build a very simple model. It's our model, and I will add the bifocals here so it's easier for you to understand. We create some window parameters where we can control the size of the windows in a very simple way, and then we just show and visualize the outlines of the objects, the wireframe of the box and the windows. And of course I forgot to add the honeybee model component that we need for sure. We need this stuff, and just go in here with the rooms, and I'm gonna add this to the group. So we have our honeybee model. What else do we need? What we saw in the other script was we need a grid. We need a grid, and that we get in honeybee radiance. We need a grid sensor, or we take the honeybee sensor from grid from rooms. That's also possible. Since we only have one room, it's fine. We just plug in here the room. We need to give it a grid size. The grid size is in meter. So we can, for example, go here 1 meter. That should be good enough. Maybe it should be smaller. Let's go here and let's do this. And it's already a certain level. That's where the actual measuring happens. It makes sense that it's not that we don't measure the floor, but we measure a certain height where it actually matters, because you're gonna have a glare in your face. So that's our grid. We need to apply the grid with this assign grid to and views. So we have the model, and we need to have the point, the grid here. Now we have a model, a honeybee model, where the grid is applied to, assigned. Now we need to make a quick excursion to Ladybug, because we need weather data. Download weather data, just put it here, and we need import. I showed how to do that many times before. Please check out my other videos. I will put relevant videos into the show notes so you can check it out. We need the weather data. Now, these are the stuff we need first. And I can see it's working. I have stuff in here. That's perfect. Now, what else do we need? How can we now calculate stuff? And what do we actually calculate? Next, what we need to have sun path. And that requires already certain inputs. We need location. We have the hours, so we can actually turn it off. We don't need to see that at the moment, but just let you know that you can actually see the sun path. In here, the hours of the year, solar center point, there we could put that somewhere else. Scale, projection, delay, and so on. But what else do we want to actually do? There is a tool that's called the Ladybug Directional Solar Irradiance. That's the tool we need. And it also needs a location. And it needs the direct normal illuminance in lux. Here the problem is that we actually don't want to mix that with the diffuse horizontal illumination. That we don't want that. So this tool is to compute the hourly solar irradiance or illuminance falling on an unobstructed surface that faces any direction. The thing is, we need both. We need the direct normal illumination, we need the diffuse horizontal illumination, but that's not in the definition of the ASE. So what can we do? First, we want to use the data and separate the header from the values, and then we combine it again. we combine the header, but with fake values, basically. And we use the duplicate data tool for that. So we create a data set. One is 0. That's actually data, and then we can multiply that to create a list. So at the moment there's 2, but we need to have the amount of number of hours of the year. So this is 8,760. That goes in here. You can see the values. There's 8,760 values in here. Now we have 8,760 values, which are 0, and that we're gonna put in here. That's our data. And that goes, we replace that here with the diffuse horizontal, because we don't want to measure that. That should be 0. And that goes into data. We also need to provide a number which defines the orientation of that surface. Because at the moment we are calculating something very abstract. The altitude here, surface altitude, means the direction of the surface, and 90 means it's facing upwards. And you can read that in Abraham's script. That's what I learn. Okay, that's how you do it. That's how he does it. Can we use the same? Can I understand it? I think I can. He also needs a statement, because what we haven't yet thought about is what actually the window does. The window has there's a certain transparency factor which we need to multiply with the lux. And we not just testing actually the amount of sun or the hours of direct sunlight, but also the intensity. So again, what do we actually do here? This is really important to understand. We try to understand from the sun vectors on which direction or location the sun has a certain amount of lux, and we want to filter that. That's why we need a statement, and we need to include the window transparency within that statement. So we want to basically only look at vectors, sun location and position, where the sun hits the inside surface with 1,000 lux. So in order to do that, we need to have 2 numbers. This is my lux value. This is my threshold. Everything above, that's what we want to check. All the vectors which are 1,000 and above. But because we have a transparency factor of the window, we need to somehow calculate that to that. And let's say the transparency is 0.6, and we can play with that. But how to calculate that together? So we need more lux in order to achieve the 1,000 lux inside. 1,000 lux hits the glass, and because of the transparency, it's gonna continue with less lux inside. So in order to get that right, we need to divide 1 with the transmittance value. That gives us 1.6. That's the number we need to multiply with the lux value to get the right illuminance threshold inside. And then we need to multiply that. And that's our multiplication. And now we need to create a statement. We need to create a statement here which filters out all the vectors which are below that threshold. With this tool, we can take portions of text and put it together. So we have our result, and we need to create a statement. It's basically another text which says A is larger than the threshold. And that goes into here. We also need to define the time. Currently, we don't have anything. Start day, start month, start day, and start hour. Start hour starts from 0 to 23, so we're going to put here 0. You can optimize it, of course, to the hours where there's only sunlight. Hours of the year should be 8,760. So now we should have vectors here. Yes, we have vectors. Basically now filter all the vectors, all the sun directions where the lux value is higher than 1,000 lux, incorporating the window's transmittance, and all the other vectors and all the other position and direction of the sunlight is taken away. That's why we only have 2,220 vectors. If I compare it with Abraham's script, he has 2,008. And that probably because what he did is he defined the start hour from 9 the end hour 17. That means he only calculates certain hours of the day and not the entire hours, which probably doesn't make so much difference. It also depends where his location is and which weather file he's using and so on. So these are all important things. Now we jump to the actual simulation. We need the simulation here. Now we use a tool, it's called the direct sun hours. It all becomes very interesting now. That we built this honeybee model is a bit, we actually don't need it that. It's just very convenient because we can create this grid and so on. But all right, if we take this, we can plug in the vectors. First of all, our vectors, we created vectors before. And then the geometry. Well, the geometry is the mesh, is this mesh here. So we have this test here. We have we input the mesh into this geometry slot. And then we need a context. The context is the honeybee model except the windows. How do we get that? Well, we can take the model. I can go in here into honeybee. There's a tool, it's called face by type. So we can take this. Should actually work with the whole model. Yes, that works. With face by type, we can actually look at these different faces. And with the honeybee object, visualize object, we can actually extract these as meshes. So for example, here we extract all the walls, and we also need the roof. There's one object in here, it's this one. So we have the walls and the floor. I make that all a bit simpler as in Abraham's script, just for the sake of having a better overview. We only need the walls and the roofs or ceilings and so on. So we need everything except the apertures, the windows. If there would be, for example, now any shades, then that would be also we would need to account for as well. I'm just checking here if we choosing the correct stuff. The roof, we have only one geometry here. That's fine. We can actually add a geometry node here and plug this in here, and we can plug that in here. So we have all these surfaces in there. Let's keep this and let's check what we actually selecting here, because with the item selector I can select. Apologize. We first need to extract these faces. By the way, we also have the external floors. We need to add the external floors that I forgot. There's just one surface here. We can add this here. And for the walls, that's a bit more tricky. We need to filter certain things. We can add a panel here. And in order to make this work, we need to add here, we need to double click, right click and go multi-line data. That gives us the ability to actually create a list. We put in here 1, for example, then we have selected that surface, that window. So that's already wrong. We don't need that. 2 we also don't need. 3, yes, we need. 4, 5 and 6, and that gives us all the walls. So this is our context together with the roof. And it's a bit thinking about a bit around the corner. We could also like create that model directly in Rhino. It's also no problem. But at the same time, you also learn something about honeybee. You can take this geometry and put it into context. And we could specify other things: grid size, offset, legend, parameters, and so on. The grid size, I would say we take from here, take the same grid size. And then we only need to have a run button. Hello, hello. Basically, that's already what we're looking for. And now, in order to make it more usable, let's check what else can we do. Tag, the 3D tag has more options. First of all, the location points again. We have the text. This is the result, and we can change the size of the text, and we can change the color. Now, what else can we do? Now we would need to calculate the area and identify all the areas which are which have a higher value than we want, which are above the threshold. You can see that's already here 293 to 274 and so on. These are higher. In order to make this chart a bit nicer, we can add here the legend parameters. We could use a separate heat map. That's also possible. I encourage you to learn from Abraham's script, but I would just add here 2000 as a maximum, and minimum can stay just 0. That's fine. Now, okay, what else? We need to try to find a way to actually use the result and calculate the percentage. I will get the whole area and then try to understand how many of these dots are above the threshold level. Get the areas of these dots and then calculate the percentage out of it. So to do that, we need first the area of the mesh. You can get this area, square meter. So we have an area of 60 square meter. This is our 100%. And there are many different ways on how you can do that, believe me. This is just one way. We have the results. And we can say all the results which are larger than 250. I mean, this is a very simple trick. This is really a very simple trick. What I'm doing here is I just remove the faces which are lower than a certain amount. Actually, I cannot use this. I will use the dispatch, the colon faces. Yes, that's the one I'm using. So I'm adding this pattern here to the tool here, col faces, and gonna get the mesh again. And now I actually removed the wrong ones. I want to invert that. Invert. And that I can place in here, and that gives me all the leaves me all the faces which are above that threshold. You can see that now we have these areas and we have that area. And now I can again calculate the area, 60 and 14. That's very simple actually. You just need to have 20, the smaller number divided by the bigger number times 100. Then you get the percentage. So x divided by y. Sorry, I was never good with equations, but I mean that should be fine. Now I just need to have the area here, and that should give me the percentage. And that is too much. I can actually do the same what I learned today. I can use this thing. That's pretty cool. Put this in here and add a percentage sign, and maybe I want to round that number. 23%. Of course, we could now add a function where we then where it gives you a text saying, as it is here,
You have failed lead.
We could do that. Please learn from these other examples. I just try to give you the logic which you can really understand what we're trying to do, and then you can refine your own scripts in the way you want. I think that's the point. Now we could actually check if we are able to reduce the window in a way that we are achieving lead. If we make this smaller, you can actually see. Okay. That would be interesting now with, I don't know, Galapagos or something. We are at 20%. All right, I hope that works for you. We will talk a bit more about the whole lead thing another time. It's a very interesting study, but I question on how useful it actually is. It doesn't say much. It doesn't say much about when these hours occur. How does it really affect the people inside? It's all a bit. I think they're better studied, but that's a story for another time. Please check out my channel, sign up as a member, and check out the Honeybee 2022 playlist. There's a lot more stuff in there you want to check out. All right, see you next time.
You have failed lead.